Okay.
Midnight.
11:59. Right. And today I'm going to pose 6 problems, six applications problems. Those problems are based on heat equation of 1 dimension, wave equation of 1 dimension, heat equation of one dimension, heat equation of 2 dimensions, and Laplace equation. Yeah. So just those 3-4 applications. 6 problems are there. I mentioned everything clearly. You just try to pick one example, just one. Solve that example by your own without taking any help. You can take the help only from our classwork, means Canvas notes, or any books, that's fine, but not any person. If some professor is just staying aside to your home, don't ask him. That's what I mean, right? Don't ask anybody, not your friends, not your colleagues, no. Solve that example, and you have to present that work on Thursday in our class. Everyone will be provided 12 to 13 minutes. All that example, you have to Thursday. You solve that example. I'm going to post those examples on Canvas in next 2 hours before 3 p.m. Then after you pick one example, but make sure once you pick the example, that means you have to mention this thing to other guys that you already picked up this one, so that other guy cannot pick that example. 6 examples, 6 people are there. 6 people, right? How many? 6 or 7?
I think there are 7 people.
We are 7?
There's 7.
Oh, I'm sorry. I have to add one more example. Okay, I will add one more example. And answer is given to you. So just, I want you to, you guys to solve that example thoroughly, understand that one thoroughly, get the answer, don't take any help, and present that work next time. Next time I'm going to say not tomorrow. Tomorrow we are going to learn something new. Next time means last day of the class, that is Thursday. You have to present that work over here in front of all of us.
So that means that that'll be our last thing, and then
That will be the last thing, and then we are done. Yes.
Okay.
Is it okay, Jennifer?
Yes. So basically we finish our current packets and turn that in on Thursday night, and then during Thursday class we present our work on the
problems which I'm going to post.
Yeah.
Good. Blaine? Good.
Works for me, sir.
Mike?
That sounds good, sir.
Okay. Fleming?
Yeah, that's good, sir. Are you going to put the answers with it so we can check our work before we present it?
Yes.
Okay, that's good.
Answer.
Yes. I don't want to present a problem and it be wrong. That way I can check my work.
No, answer will be there, and you have to make sure that you are getting the right answer. And yeah, you have to present your work day after tomorrow. You can do one thing before your presentation. If it is possible, just send the file to me, submit your file on Canvas, or you can send the email to me. I don't mind, that's fine. Send it to me so that I can at least go over that before your presentation. If it is possible, that's not mandatory, that's not compulsory. But if it is possible, because the compulsory thing is your homework. Because your homework, your class participation, your presentation, all these things will be counted your final grade. You know this thing. And you guys have selected this one, right? This page and presentation type of things. That's not my plan, but last time you said this thing, and finally I figured it out this thing that let me give you just one example each. Solve that example and present your work individually in 12 to 13 minutes each. Because 12 multiplied by 7, 12 multiplied by 7 means how much? 84, right?
Oh, yes.
And 84, and we have 75 minutes. So let me take 11. 11 multiplied by 7 is 77 minutes. Okay, so 11 minutes. 10 to 11 minutes, 10 minutes, we can say.
Mm-hmm.
Right? And that's not a big deal. You can just present this work, and everyone has to pay attention. If somebody finds some mistake, or if somebody doesn't understand the thing, suppose Jennifer is presenting her work, and suppose Fleming is not getting some point, he can ask that question to Jennifer. Yeah. Right? Or suppose Mike is presenting the work and Blaine is not getting, he can ask. Now there is no grouping for this one. There is no group. It's individual thing. Make sense?
Mm-hmm.
Right, guys? Okay, guys. So shall we stop here?
All right.
Okay, guys, thank you so much. And again, I think that window is open for the student evaluation. So please fill up your form. I tried my best, guys, because this is not that easy to digest. I know this thing, and it's equally not easy to teach at 400 level, but I tried my best. And whatever we have decided in the beginning of the semester, we ended up to the same part. I told you that I would like to go through at least 2 or 3 applications. Already 3 applications we have finished, and we are going to cover one more tomorrow. So I think we are in good shape. We have covered whatever we have decided. Right, guys? And yes, one more thing. In future, suppose you decide to go for your graduate school and suppose you are going through the same type of things. And if you want the exemption of that course, just send an email to me. I will be glad to send a letter to you or your university so that you can get the exemptions of this course. Right? Because this is a course, this course is being taught at 500 or 600 level in your graduate level course. Right, guys?
Mm-hmm.
Yeah, that's what I can do for you. If you need any of the helps, don't hesitate. Let me know. Just send email to me, or we can discuss over here, whatever you feel good.
Thank you.
Mm-hmm.
Thank you, guys. Thanks for your time. Thanks for this 10-15 minutes.
Sure.
Take care, guys. And I'm going to post those things very soon. Okay, very soon, before 3 p.m. you will find it. 3 p.m. Eastern time.
Good.
Yes. Thank you. Take care. Bye.
Bye.
Sir.
Yes.
Sir, so for this homework that we're turning in on Thursday or Thursday night, not the question, but like actual homework packet, we're still in our groups on that, correct?
Say again, I lost your voice. Last sentence.
We're still working in groups on that last homework.
Yes. You're still working in a group, but all of you have to submit the same file. Suppose you 3 people are there, you, Zach, and Blaine, yeah. So please submit the same file so that I can grade, and you can see your grade. Because yesterday I just put the grades for Zach, so Zach can come to know this thing, and you guys are getting the same one. But you cannot see that one on Canvas. So if you want to look at your grades, you have to submit your file. Because without submitting file, it's not possible for me to submit the grade.
Mm-hmm.
Right? Yes.
Right, sir.
For those presentation work, just one problem that you can submit to me. Just send the email to me, right? I think that sounds good. Or if you want, you can submit to Canvas. I don't mind, but email is good for me.
Okay.
Right? And don't send zip folder, because yesterday I was facing some problem opening the zip folder. Fleming, he sent the zip folder to me. I figured it out, but I faced some problem. So please don't send me a zip folder. I don't, something is wrong in my computer probably. Anyway, but yeah, so that's the thing. Sounds good?
Sir.
All right.
Yes, sir.
Thank you, guys. Stay safe. Take care of yourself. Stay happy.
Yes, sir. I tried my best to upload the file.
Okay.
Which is hard.
Fleming, we will talk about your issue probably, whatever you discuss with him, probably sometime. Okay, some other time, maybe tomorrow or maybe on Thursday. Okay. Fleming. Okay. Or you can,
Bye, sir.
Evening. You can call me around 7 p.m. in the evening, 7 p.m. Eastern time.
Okay, sir. Will we know our final grades going into the presentation?
Final grade after the presentation, you want to know?
Yeah, how will we know our final grades? Because I don't know what my grade is right now.
All of you are working really good right now. So I would say that all of you are on around B or A. Nobody is on lower B or C. So everyone is good so far. And yes, I will let you know this thing too.
Okay, thank you, sir.
Okay, no problem. Guys, it's a time for my class at 1. So I think already it's 12:52. So let me stop over here, and I want to start with my class after 5-7 minutes.
All right. Thank you, sir.
Thank you, guys. Bye.
Bye.
See, students are coming coming here. Mion, how are you? Guys,
sir.
and you can sign off. Yeah, okay. Yes, Mion, how are you?
Good. How are you, sir?
I'm okay. Just waiting for you guys. I was just talking with my 400 level students. I was talking.
Oh, I'm a little early.
It's okay. It's okay. We are done. They already have gone. Situation is getting crazy. It's very scary over here. You know, in Harrisonburg, I stay in Harrisonburg, and we have 300 cases here in the town.
Really? Wow.
300. I'm scared. I'm scared now because I have to go for at least my groceries after a week or like this.
Yeah.
I'm afraid of.
Yeah. I mean, my mom's a nurse, so she's been doing like classes to people on what to do and everything. And if you just constantly sanitize your hands and wear the masks and keep your distance, you are almost guaranteed not to get it. So
no, you are right, but you know, people are not that. People are educated, but they are not. They don't have that sense to keep the distance. I went to Walmart last.
Oh no, yeah.
And some people they just passed through me. Just it was just half feet distance. I tried to keep distance. I went far from him, and they didn't mean it. They were just laughing at me. I don't mind.
Oh, I know.
But they were just passing just side to me, and oh my gosh, without any mask, without gloves.
Yeah.
Crazy.
Yep. There's a lot of people doing that.
Oh yeah. They don't know the seriousness of this issue. They really don't know.
No, sadly they don't.
Yeah, that's unfortunate part, and I think that's the reason why we have a number of deaths over here in the United States.
Yeah, no, I agree.
If you are not particular about yourself, no one in the world can help you out.
No, I know.
Be first particular about yourself. Then you can ask for the help. But these people, that
exactly
ridiculous. Most likely today we have a last class. And day after tomorrow, or I mean say, yeah, day after tomorrow, if you want, I can give you the exam, or if you want, I can give the exam on the last day of the class on Monday, next Monday. So it's up to you.
Okay.
But let me first finish the syllabus once we are done. And if all you guys agree, because I told you last week, right, that you are taking your exam on Wednesday. Am I right?
Yeah, you said
yeah.
If we get all the content done.
Yeah. Yeah, so that's what we want, and yep. So we are exactly on time, even though this typical situation, online teaching and learning process, first time for all of us, still we are on time and everything is done.
You have
it worked out pretty well.
Hey, John Daniel.
Hey, sir.
John Daniel, where are you? I can't hear you. I can't see you.
Yeah, let me. Yeah.
Okay, now I can see you.
Do you have the study sheet for the test 4?
I think it's already there on Canvas. Before I start, yeah, it is there on Canvas. Just make double check.
Let me see.
Before starting the chapter, you can first see the practice test, and then after I start syllabus. Is it there?
I'm checking right now.
Yeah. If you don't find it, please let me know so that I can post it very soon.
Okay.
Is it there?
Oh yeah, test 4.
Yes, test 4. Yes. and practice test is there. And then after our syllabus started. Yes or no?
Yes.
So you got it, right?
Okay.
Thank you. Yeah, somebody told me last week and I just went over the Canvas and whatever I posted on Canvas and I found it.
Yeah, I emailed you last week.
Yeah, because that's my usual habit. Usually I'm giving you the practice test, all you guys practice test before I start the syllabus so that you can have enough time to look at the problems. Suppose I cover 2, 3, 4 articles of that chapter. And if you want to compare those articles with your practice test, at least you can come to know that this article is given or is taken from this chapter, this point. This question is taken from this article. So that's my usual habit. Usually I'm providing my practice test well in advance before I just start the chapter. And that's what, right? Daniel?
Yeah.
Good. Yeah, so please go over everything and yeah, time start. Where is Rollster?
What's the test next Monday?
No, day after tomorrow.
Tomorrow?
Day after tomorrow, Wednesday.
Wednesday. The test is Wednesday.
Yep.
Okay.
Is it okay? Sounds good.
Yeah, I guess.
Davis, are you there? Ralston. Yeah, connecting to Ralston. Davis, are you there? Hi, Ralston. How are you?
Good, sir. Yourself?
I'm good. Thank you. I'm just scared because yesterday I've heard that in our town we have 300 cases.
In Lexington?
Yeah, 300 just in Harrisonburg town. So it's 50,000 population and 300 cases. Too much, right? So now that's scary. It's exactly 1 p.m. Ralston, can you start the presents, please?
Yeah.
Yeah, please go ahead.
Of the sheets. All right, Cox.
Here.
Bayer. Bayer.
Why people are not coming in time?
Bryant. Bryant. Calhoun.
Here.
Caulfield.
Here.
Other Cox.
Here.
Daniels.
Here.
Davis.
Come on, Davis, where are you?
Davis. Grote.
Here.
Hanley.
Here.
Harris. Harris. Lamb.
Here.
Lawrence. Lawrence. Meon.
Here.
Nefferdorf.
No, he dropped the course.
I dropped it.
Yeah, just yesterday I came, he sent a form to me. I signed the form and sent back to the registrar's office.
Okay. Rippy.
Here.
Sanzone. Sanzone. Seaman.
Here.
Whitaker. Whitaker.
I'm here, by the way. Davis.
Davis, yeah,
Okay.
Sorry, I
we are looking for you. I shouted 3 times. Okay, Davis is here now. Okay,
Yeah, sorry,
Davis.
I just got in here. I noticed what time it was.
That's fine, no problem.
Harris is here too.
Harris is here.
Seaman is
Yes.
here, yeah. Rice Seaman is here.
Okay.
And what about Lawrence, Michael Lawrence?
Yeah, he's not here.
This is his 4th time he is not here. So now I don't know he's going to lose the points because it's 4th time now.
Okay.
I thought I remember him talking about dropping the course. I don't know if he went through with it or not.
Michael Lawrence, but I didn't get the form. I
Yeah.
didn't get the message from Dean's office or I didn't get the message from him.
Yeah, like I said. So I'm not sure if he went through with it or not, but I thought that was what he told me a while back.
Uh-huh.
Okay.
And Bayer, B-A-I-E-R.
Yes, sir.
Where is he?
Yes, sir.
Bayer, I can't see you. Can you see him? Okay.
I see him.
Bayer, what's wrong with you? You were not here since last 3 classes.
I was here last class, sir.
Last class, I think you came late, right?
Last Wednesday. I
Yeah,
don't think so,
you
sir.
came late before he took the present. I mean, say you came after he took the presents, right?
I don't believe so, sir. But
so you were there last class. What's about last to last class? Last week you were not there. Means following. Yeah.
I guess not sure.
Says that you had now 2 absence. If you said last Wednesday you were here, let me cancel this one, but I have 2 absence. Anyway, just make sure we have to go through next 2 classes, Wednesday and Monday, right? So
Yes,
please be particular, please. If somebody has joined us after Ralston took the presents, please let him know, please. It's not his job. He's done. It's your job to let him know that you are late by a few minutes. Okay, sounds good. Can you see the screen, guys?
Yes, sir.
Okay. Guys, look at over here. Most likely this is the last lecture. If yeah. So I would like to the syllabus in next 50 minutes. If not, then we'll decide. Otherwise, once we finish the syllabus, you are taking your exam on next Wednesday, day after tomorrow. And that's what I told you last Wednesday, that you will be taking your exam after a week. So still, I am on my words. We are on the same page. All you guys agree with me? Davis?
Yes, sir.
Davis? Davis, I'm asking you.
Yes, sir.
Please do reply, please. I'm waiting. Okay, guys, so just look at over here. Last time we started the transformation. I told you transformation is nothing but a function and transformation is nothing but a matrix. So once we are given the transformation, how can we generate the matrix using that transformation? And that's what we did. And whenever we have function at that time, here R2R, or you can say R1 to R2, but that is not always possible. Sometimes it could be R2. It could be some other dimension over here and some other dimension over here. It could not be always same. Here you can say I gave the example of F runs from R3 to R4. So 3 elements are in the domain and 4 elements, 4 dimension is 4 by 4 in our codomain or range. So Fx equal to x square like this. Okay, fine. So then after we went over the examples, so define the transformation where 2-dimensional vector is transformed into another 2-dimensional vector. So R2 to R2, so define the transformation in which the 2 dimensions, once you take one x, see where always this x, look at my cursor, this x always comes from the domain, first one. And ax, this x from right side of the equality, it always comes from the codomain. So please keep in mind this thing. So x is a 2-dimensional vector. This x comes from here. And this x is a vector, output vector from second R. Second R, I mean to say this codomain R actually. I should have written codomain. And here it is domain. So please make sure. R2 is a domain. Always first one is domain, second one is codomain. And you can see over here R2, X1 and X2, but my this mapping is defined in such a way that I'm having 3 elements over here. So X1 square means of the first element. First element is multiplied by 2, is counted as my second element in my codomain, and product of X1 and X2 over here as my third element in my codomain. So always keep in mind this thing that once you use the transformation, that doesn't mean that you will be having the same kind of dimension. No, it could be different. It could be same, it could be different. Linear transformation, we went over this one, and I told you that this must be satisfied. It is linearly addition in linear and scalar multiplication. So vector addition and scalar multiplication. We went over this example last time. This was the example. Look at over here, 3, -2, and this one. So first I took tx, then ty, and tx plus y, and then t of x plus y. And I just made sure that tx plus ty is same as this one. Both are same. So that means it is, sorry, they are not same. That means it is not linear. For linearity, both the conditions, as I told you, both the conditions must be satisfied. First and second, both the conditions. If here first condition violates, means we can say it's not linear. Sometimes it may possible first condition is good, but second condition violates. In that case, again, you can conclude the same thing, that is not linear. Like this. Okay, second example, look at over here. In the second example, yes, tx plus y equal to tx plus ty. Look at over here. So first condition is good. Let's go for the second condition. T of kx equal to k times tx. Is it possible? Suppose I take k equal to any constant. You can take 2, 3, 4, 5, 7, -5, whatever you want. I took 7. So 7x equal to tx is defined in this way. So 7 is multiplied with my entries. My entries means my x, right? So 7 is multiplied with this one. Okay. So 7 3s are 21. 7 2s are negative. Negative 2s are negative 14. And that is nothing but my mapping A. So A of this one. But A was defined like this. So you can pull this 7 out and like this. So 7 of tx equal to 7. T of 7x equal to 7 of tx. So both the conditions are satisfied. That means we can say this one is a linear. There are different ways of checking the linearity, checking the linear thing. So please keep in mind this thing. There are different ways of checking the linearity. Okay. The above definition T is linear is true in general, not for just one example. Okay. It should be true in general. Okay. Not just for one example. So in general, some k, any number k, any constant k should be multiplied by your vector, and that transformation must satisfy this condition, and vector addition must be true. So these two conditions must work together. Okay, so that's what we have seen last time. Now I would like to start with the matrix and linear transformation. How can we add matrix and the linear transformation T? What is the relationship between capital T and your matrix A? Relationship between capital T and your matrix A. Look at again, I just put the symbol Rn to Rm because I told you that it could be same, it could not be. So it depends on the transformation T. So Tx equal to Ax. This T transformation itself is your matrix A. Look at here. So things are, suppose you are given the transformation, how can you fix your matrix? Or vice versa. Suppose you are given the matrix, how can you fix your transformation? Most likely, I'm going to ask you like this, that suppose some transformation is given to you, and I will ask you to fix the matrix related to that transformation, which makes this equation true, which satisfies this equation, Tx equal to Ax, where A is m by n matrix. Whenever you write the matrix, that makes sure that A takes this form, m, look at my cursor, m to n. M to n. Don't come from n to m, please. A, whatever matrix is being formed through your transformation, its dimension is m to n. M to n. Make sense, guys? M to n. And that's dimension A is m by n matrix, then T is a linear transformation. T is a linear transformation. So whenever this condition is satisfied, means for the given transformation, you fix your matrix, and if this equality holds, it's a linear transformation, right, guys? So I gave you one definition previously, T of x plus y equal to Tx plus Ty, and Kx equal to K times Tx. If these two conditions satisfied, linear. Second thing is, if this condition holds, so either way, those two conditions are satisfied, linear, or if equality is there, linear, and that linear, once this equality holds, whatever the transformation of matrix you are going to get, that is always unique. Means there exists only one matrix, unique matrix A, which satisfies this equality. That means one matrix satisfies this equality. There is no any other matrix which will satisfy this inequality or this equality. Are you getting me? My dear friends, are you getting me?
Yes.
Yes.
Sir, I'm getting you.
Yes, sir.
Okay. Caulfield?
Yes, sir.
Okay. Then Davis?
Yes, sir.
Okay. Then Nathan Lamb, Rolston. I hope all you guys are good, right?
Sir, you know I'm good.
Thank you. And guys, my student evaluation window is open. So please go online and try to fill up the student evaluation form because that is open till I think till this weekend. So please do this thing as soon as possible. I tried my best to convince you. I posted the notes and everything well in advance. And when the online teaching started, I've been trying my best, guys, to convince you. So please give your own honest opinion. I would appreciate that thing. Anyway, let me continue. So standard matrix of a linear transformation. See, T is Rn to Rm be a linear transformation. By above theorem, the matrix A such that Tx equal to X, equality satisfies. This matrix A is called the standard matrix. Whatever matrix you are going to get from this equality, There is a standard matrix. And this standard matrix is denoted by capital. Actually, it is called, you can say bracket T. Yeah, right now you can say bracket T. Otherwise, the word is different, but I don't want to expose that thing over here. Okay, so capital T. Now the question is, how can I fix this capital T? To fix this capital T, just ignore this part. Okay, one more thing. The standard matrix A is linear transformation. See, linear transformation now we are going to see by fourth different way. First one is two conditions, tx plus y equal to tx plus ty, t of kx equal to k times tx. Second one is tx equal to ax equality. Third one is to find this bracket t from this tx equal to ax equality. Fourth one is Rm to Rn be a linear transformation. Each of the entries means these entries. Once I say that, then T is M by N matrix. Each of the entries that is of this form. TE1, TE2, TEN. So this T, whatever I was talking about, how to fix my T, how to fix this T is nothing but TE1, TE2, TEN. So thing is, how can I find my TE1, TE2, TEN? Because this T is nothing but my matrix A. This T is a matrix A. Look at my previous thing. This T is a matrix A. Tx equal to Ax. Tx equal to Ax. The matrix A is called the standard matrix of the linear run. This matrix A is called the standard matrix, and there is this one, bracket T. So bracket T means standard matrix A. Bracket T means standard matrix A. Okay, my dear friends, let's go with this one. So TE1, TE2, and like this. Let me take this example. Once you understand this example, everything will be clear to you. All of you, I want full attention. All of you guys, just pay attention here. T is R3 to R4, be the linear transformation where T x1, x2, x3 is given like this: x1 plus x2, 3x1 plus blah blah blah. Here 3 elements are there. These 3 elements are being transformed over here to 4 elements. So R4, 3 dimension to 4 dimension. Now TE1, you know, E1 means how many elements are there? 3 elements in the domain, right? That means I have to start with 3 dimension. 3 dimension, I mean to say that here E1, because see here E1 there, E2 there. You know, E1, E2, E3 standard matrix is 1 0 0 0 1 0 0 0 1. E1 means 1 0 0. T on E1. So X is 1, replace here. Replace your X by 1, X2 by 0, X3 by 0. X1 is 1. Right? So X1 is 1. If you write X1 of
Yes,
1
sir.
here, so 1 plus 0 is 1. 3 multiplied by 1 is 3. Otherwise 0. And here it is 0 and 0. So 0. And here it is 4 times 1, 0 and 0. So 4. So I'm going to get 1, 3, 0, 4. Agree? Look at my cursor. All of you agree with me, guys?
I agree.
Yes, sir.
Yes, sir.
Good. Thank you, guys. Please respond, please. Same E2. E2 is 0, 1, 0. 0, 1, 0 means x1 is 0, x2 is 1, x3 is 0. Plug the values here. x1 is 0, x2 is 1. So 1. Here it is 0. Here it is 2. Here it is 3. Can you see 0, 1, 2, 3? That is my TE.
Yes, sir.
Yes, sir. I see it.
Thank you, guys.
Yep.
TE3. TE3. 3 is 0, 0, 1. 0, 0, 1 means x1 is 0, x2 is 0, x3 is 1. Just plug the values. 0, x3 is 1. So negative 1. X3 is 1. So 5. X3 is 1. So 2. That's what I'm getting here.
Yes, sir.
Right? Plug these values TE1, TE2, TE3, whatever you are getting in your standard matrix T. So TE1 is 1, 3, 0, 4, this column. TE2 is 0, 1, 2, 3. TE3 is 0, negative 1, 5, 2. That is my TE1, TE2, TE3. And this is my standard matrix, means this is my matrix A. Agree, guys? So look at the last line. Last line A is just these columns are being transformed over here in the matrix form. Agree?
Yes.
Sir.
Out.
Yes, sir.
And here, this is the checkpoint. I just took some solution. Suppose 1, 2, 3 is my X. Because X is not given. Suppose 1, 2, 3 is X. And that is equal to X1, X2, X3. So Tx equal to this 0, 3, 19, 16 for 1, 2, 3. And matrix AX, A is this one, whatever and 1, 2, 3, AX is this one. And you can see Whatever the numbers I'm getting over here by tx, exactly same over here for tx. Means tx equal to ax is satisfied. This transformation is a linear transformation. Makes sense? Because this condition is satisfied. Agree?
Yes, sir.
Another approach of looking the linear transformation is here, guys. Look at here. Linear means just one. Linear means one. Always keep in mind this thing. Linear is one. Where I was. No. Yes. Linear means one. That means you have to have the power of your variables one. It should not be fraction. It should not be any radicals. It should not be any kind of multiplication. x1, x2 like this. So power of your variables are one and they are separated by plus or minus signs. Not multiplication, not division. That is linear. Always, this is just a very easy way, layman's way, I would say, to understand the linearity. I repeat, power of all your variables, x1, x2, x3, x4, what it may be, should be one, just one. Not fraction, no radicals. And they are not multiplied together. Means you cannot find x1, x2 multiplication or x1, x3 or x2, x4, something like this. You cannot find any kind of multiplication. So here, no multiplication, all the powers are one. So these are linear transformation. And that's why this condition is satisfied. Makes sense. So I gave you another way, another approach to look at the linear transformation or linear matrix. Makes sense?
Yes, sir. Would you ask specifically which way to approach it, or would you be okay with us doing it?
No, it's up to you. I'm not going to ask you specifically. Most likely, I'm going to ask you like this: that if for this type of example, look at here, this standard matrix type of example. That's what I'm going to ask you. This one, this type of example. Okay, just standard matrix C. So you have to go through this one, right?
Perfect. Thank you, sir.
No problem. Okay, now standard unit vector. Just I use this one, unit vector. This is called the unit vector in 2 dimensions, unit vector in 4 dimensions, 3 dimensions, just we finish the example. And if you plug that T1, T2, that will give the standard matrix. Just the definition. Already we solve the example, so definition doesn't make any difference now. It's good. Okay, but I would prefer you guys to go through each and every line of these notes. Probably that will give you a better idea for your objective questions. Condition on linear transformation. What is a condition? Rn to Rm be a transformation and consider the entries Tx equal to T of x1, x2 up to xn. Right? Rn, so n vectors, and Txm, this resulting vector is m, is linear if and only if each of these vectors, see here, if each Tx means this one, Tx1, Tx2, Txn, all this T of x1, T of x2, T of xn, all of them, they are of the form a1x1 plus a2x2 plus a3x3 up to an xn. You can here, powers of x1, x2, x3 are 1. Look at here. Constant doesn't matter. I don't count constant. Constant, you can write root 2. I don't mind. But it should not be root x1. Root x3. Right? So that is a linear transformation. My next example, I wrote 5 different examples over here. And I want to take one by one. Look at here, guys. First example. Pay attention, guys. Pay attention. We are almost at the end. Maybe the last lecture. x1, x2 is defined like this: x1 plus 1 and x2. What can you say about this? Is it linear or not?
Yes, it's linear.
Why?
Because x1 and x2 are, there's no powers next to them.
Okay. Again, I would suggest you to look at this definition, last definition. Each of your entries should be of the form a1, x1, a2, x2, a3, x3, an, xn. Can you see every time between plus signs, every time I have one variable, x1, x2, x3, x4, xn, right? But there is no constant. There is no only a1 or a2. All a1, a2, a3, they are associated variables. Can you see my 1 is separate here? Mion?
Yes, sir. Yes, sir.
Would you want to change your answer now?
Yes, sir.
What's the answer?
It's not linear.
Non-linear, because additional 1 is there in the first row. Agree?
Yes, sir.
All of you agree with me or not?
I agree, sir.
Can you actually say that again, sir?
Look at this. This is another one of the definitions of linearity. It says that all your entries, means all these entries, Tx1, x2. Tx1, x2 means this one, actually this one. must be of the form a1, x1, a2, x2, a3, x3, an, xn. Means x1, x2, x3, xn are separated by, all the variables are separated by plus sign. Otherwise, just 0. And there is no multiplication of x1 and x2. x1, x2, x3, x4 like this. No multiplication. But there is no even any constant. See, it's not like this. a1, x1, a2, x2, an, xn plus an plus 1. No. Every constant is multiplied by some variable. Agree?
Yes, sir.
Who is there?
Yes, sir.
Okay. So can you see this plus 1 is just the additional factor which doesn't fit in this equation. Am I right? Because plus
Yes, sir.
just the constant without any variable. Agree?
Yes, sir.
Right.
Agree, guys, all of you?
Yes, sir.
Okay, so that's why this one is not linear. What can you say about this one? x1, x2. x1 by x2 and root x2. So simple. Linear or not?
That's
Yes, be confident.
yes. Yes.
Yes.
It's linear.
x1 divided by x2. Can you find any division over here? No.
Oh, so no, so it wouldn't be
By
linear.
x2. No. Root x1. I told you there should not be any radical or fraction. Root x2 means x to the power half. It's a fraction.
Okay. So it just
both
has to
ways,
be,
both these
right.
elements they don't satisfy this formation. So not linear. Agree?
Yes, sir.
Daniel, both Cox, Rolston, Davis, Lamb.
Agree, sir.
Yep.
All of you.
Sir.
Caulfield.
Yes, sir.
Caulfield.
Yes, sir.
Okay. Good. What can you say about 3? x1, x2. Look at here. Root 7. Root 7. But x1 is separate. Root 7 x1 minus x2. Yes. And pi x2. Hurry up. Root 7. Just constant. My variables are, power of variables are 1. Still 1. 1 and 1. 1. And pi is also constant. 22 by 7 or 3.14. Just constant. So constant could be anything. Constant is multiplied by variable. Here, constant is multiplied by variable. So it is a linear. Makes sense.
It's linear. Yes, sir.
Daniel,
Yes, sir.
all of you, make sense?
Yes, sir.
Yes, sir.
Sir.
Okay.
Sir.
T1, T2, T3. Let me take one number, T98. Just the name. X1, X2, R2 are being produced to x1 square to x1 plus x1 and x1, x2. What can you say about this one? Linear or not?
Not linear. Because it's squared.
Who spoke? I can't.
Caulfield, sir.
What's the name? I can't see you.
Caulfield, sir.
Caulfield. Okay. Hey, Caulfield. Yes. What should be the answer? Linear or not?
Not linear because it's squared.
Correct. Is square here and last one is product 2.
And also you got multiplication there, right?
No, multiplication is constant multiplication. But this multiplication is yes. Agree.
Yeah, that bottom one is wrong.
Bottom one. Yes. Okay. What can you say about this one, guys? Now,
That's linear.
from all of you. Hurry up, guys. x1 plus x2, 3x1.
Linear.
Linear, right? It is linear.
Yes, sir.
Here because every entry satisfies this formation. Okay, so there's just explanation given to you. Just the same things are given over here. Go through all these examples, guys. I solved the examples for you. Exercise problems I solved for you guys. Please go through it, please. Now let's start the visualizing vectors. Vectors in 3 dimensions. Last article of our chapter. Oh, so our syllabus. Last article. We know the vectors about in 2 dimensions, right? X1 and X2. Just X and Y plane. How can we draw the picture in 3 dimensions? 3 dimensions. So there's the question. Now, suppose I want to draw one vector 1, 2, 3. 1, 2, 3. Okay, guys? Now you guys have to pay attention over here. Whatever I am doing here, just pay attention. So, Whenever you are you want three-dimensional figure, always draw the picture like this. X, Y, and Z. Can you see this picture? Just
Yes, sir.
the axis.
Sir.
Now label this one. 1, 2, 3, 4, 5, 6. Just for the sake of convenience, go up to 6 or 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. This is the labeling. Agree? This is the labeling.
Yes, sir.
Let me go for the negative space, negative X, negative Y, and negative Z axis. And I just would like to denote this one by dotted line. Can you see these dotted lines?
Yes, sir.
Okay. Let me put the numbers on dotted lines too. -1, -2, -3, -4, -5, -6, -7. This is my three-dimensional axis, negative and positive axis. Agree?
Right, sir.
All of you agree with me?
Yes, sir.
Yes, sir.
Rolston? Rolston.
Sir. I agree.
Okay, now look at here. I want to plot this 1, 2, and 3. Means 1 corresponds to x-axis, 2 corresponds to y-axis, 3 corresponds to z-axis. So let me take 1 on x-axis and 2 on y-axis. Always try to make a rectangle from first to x and y. Make a rectangle. Always you will be getting one kind of rectangle. Just look at here. Kind of rectangle with your corresponding axis, x, y, and z axis or negative. Can you see this rectangle? I took 1 from x-axis, 2 from y-axis, and I try to make a rectangle in this format. Agree? Agree?
Yes, sir.
Agree.
All of you, Davis?
Yes, sir.
Colford?
Yes, sir.
Okay. Now I have this one, last element, that is 3. 3 along z-axis, Meon.
Yes, sir.
3 along z-axis. Go 3 points up from this cross part. Whatever the cross you can see here, just go 3 points up in cross direction. I mean, say cross part in z direction. So 1, 2, and 3. 1, 2, and 3. Can you see my dot? Can you see my dot here? Because I just went 1, 2, and 3 points up. 3 points up. You can draw the line, dotted line. 3 points up, dotted line. Join your dot from your origin. Join your dot from the origin and put the vector. That vector itself is your vector. Let me use the another pen, vector V. Join this one from your, can you see my black pen? Vector V. Join this dot or origin to the dot. That is your vector, and that is your vector V in 3 dimension. So that's what I mean by 1, 2, 3 in my 3-dimension space. Make sense? Okay, Mio,
Yes, sir.
I'm asking you. Give me any 3 points like this. Give me any 3 points. Mion.
Oh, you're talking to me. 4, 3, and 6.
Give one negative point. Anyone?
Negative point. All right, so 4, 3, -2.
4, 3, -2. Okay, let me write it down for you. 4, 3, and -2. So neon, he gave me this vector, 4, 3, and -2. Agree? 4 x-axis, 3 y-axis, -2 z-axis. So 4 is my x-axis and 3 is on my y-axis. 1, 2, and 3. So you can see over here, guys, look at here. 4 is my x-axis. 4 is on my x-axis. 3 is on my y-axis. 3 is on my y-axis. And I can make this rectangle. I can make the rectangle like this. So 4 is my x-axis. 3 is my y-axis. Always use the dotted line. Shall I get this kind of square or rectangle? Yes, sir. And my last point is -2. -2 means it goes to negative z-axis. So 2 points down. Always put a cross and then dot. Can you see this dot? That is my -2. Agree?
Yes, sir.
That means my vector, whatever neon gave it to me, 4, 3, and -2, let's write this vector like this. And join this dot from the origin. So let me use some other pen. Probably you can figure it out. You can realize this thing. So use this dot from the origin. And I would like to say this is as V2. So this is my V2. Can you see my green, my blue line?
Yes, sir.
So that is the vector in origin. Make sense? Make sense?
Yes, sir.
All
Yes,
of
sir.
you? Girls?
Sir.
Yes, sir.
Good. Guys, please don't forget to fill up the student evaluation, okay? Okay, guys, so that's what is mentioned over here. Now, see some other vector. Vector is just plotted like this. One vector is here, second vector is here. See? And vector is plotted like this. And now I want to go through on the same graph paper. I want to go through this one. 4, 2, 4, 4, 2, 4, and -2, 1, and -1. Right? So let me go through this one now. 4, 2, and 4. Same graph I want to use. You don't use same graph, please. 4 is x-axis. So 4 is x-axis. Sorry, 2 is x-axis. 2 is x-axis. 4 is y-axis. 4 is y-axis. So I have 4 and 2. Oh, my pen is not working. Please look at my pencil part. And I put the cross. So 2 and 4. And 2 in 1 and 2 points up. So that is my, can you see here? Can you see this point?
Sir.
Yes, sir.
Yes, sir.
Okay. Join this point from origin, that is my vector V. This point from origin, so that is my vector V. Look at here, guys. I joined that point from vector from origin, and that I gave the name vector V. Agree?
Yes, sir.
Okay. Now vector U is given -2, 1, and -1. -2 is negative x-axis, -2. Then 1 on y-axis. So I have my rectangle in this form. And -1, 1 point down. So this is my 0. Can you see this part, guys? 1, sorry, -2 means negative x-axis, 1 on y-axis, and 1 point down. If I join from origin, if you join from origin, that is your vector U. This is called -2, 1, and -1, and this is your vector U. The vector, whatever you are getting over here, that was V2, 4, 2. 2, 4, and 2. I have these two vectors, guys. Look at my blue lines, not the line below, but these two lines, this one and this one. Agree? This one and this one. Agree?
Yes, sir.
Yes, sir.
Now, if you want if you add these two vectors, so V is 2, 4, 2, U is -2, 1 and -1. So what is V plus U? 2 minus 2 is 0. 4 plus
0, 5,
and 2 minus 1 is 1. So 0, 5, 1. Plot this one again. So 0 means x-axis, 5, 1, y-axis. So 0, 5 and 1 just below z-axis. Or 1 is above z-axis, right? So look at here, guys. Zero here, 5 points here, so 0 and 5, and 1 point above me. This vector goes from the middle of these two vectors, U and V. So this vector goes to the middle of these two vectors. So this is my V plus U, U and V. Middle of these two vectors, U and V. Agree?
Yes, sir.
Yes, sir.
Make a parallelogram, because vector addition always follows a parallelogram. So make this parallelogram. So parallelogram will be like this. Get here. So this parallelogram, that is the vector addition, means U plus V. Am I right?
Yes, sir.
Join the vectors, make a parallelogram, means you are adding two vectors. Agree? Yes or no, guys?
Yes, sir.
Yes, sir.
And suppose somebody says that I want V minus U. So what is V minus U? V minus U, negative. So 2 minus minus is 4. 4 minus 1 is 3. And 2 minus minus is 3. So 4, 3, 3. 4, then 3, 4, then 3 and 3. Right? Always keep in mind this thing. U minus V. U minus V means whatever vector U and V found, just join those two vectors U and V. So I can use black dark pen over here so that you can figure it out. U minus V is, look at this line. Joining vector U and V will give you U minus V, always. Joining vector U and V, that is your U minus V. Agree?
Agree.
Yes, sir.
All of you?
Yes, sir.
Good. So now, vector addition, subtraction, everything is done. Vector addition and subtraction. This is vector addition. Look at here. We went, this is the parallelogram. The parallelogram. And if you join this, just U plus V, yeah, and vector U minus V. U plus V is this one. U minus V. U minus V is just adding these two vectors. See, V is here, U is here, just join U and V. Minus V. U minus V. Right? Same here. Then scalar multiplication. Suppose you plot one vector 1, 2, 3. So 1, 2, 3 vector is here. 1, 2, 3, that is here. Here. If I multiply the same vector by 2, means I'm going to get 2, 4, 6. Agree? Am I right? 1, 2, 3 is multiplied by 2. So 2, 4, and then 6. 2, 4, 6 means we are just extending. That is, here it is 2, 4, and 6 is here. So we are just extending this line. If you multiply vector V by -1, so you are going to get in the reverse way. So that's what we mean by the vector addition, subtraction, and multiplication, scalar multiplication. That's it. So I told you guys, and I've been telling you, please, please, please refer our classwork thoroughly. If you have some questions, let me know. Exercise problems, again, I solved a number of problems for you. See, 1 to 4. I solved all these 1, 2, 3, 4 problems from a book. So that just practice this one, solve by your own, and try to match your answer, your figure with my figure. And finally, vector length. Now I found my vectors. But what is the length? What is the measurement? What is the length of this vector? That's what we are looking for. What is the length of the vector? So for 2 dimensions, you know that length of vector is given by x equal to square root of x1 square and x2 square, right? If your vector x is equal to x1, x2, look at here, look at my blue pen bottom part. If x equal to x1 and x2, if x equal to x1 and x2, so length of the vector is x1 square, x2 square. Agree?
Yes, sir.
In 3 dimension, one more coordinate, one more. If it is x1, x2, x3, so x1 plus x2 square plus x3 square. Look at here. In 3 dimensions, you are increasing one more coordinate. So x1, x2, x3, it is x1 square plus x2 square plus x3 square. And that's it. And suppose I want to find the vector length of this vector 1, 2, 3 from where we have started. See, v equal to 1, 2, and 3. So length of vector v is 1 square plus 2 square plus 3 square. So 1 plus 4 plus 9, and that is equal to 14. So length of vector v is 14. Square root of 14, agree?
Agree.
Square root of 14 means 3.6, something like that. Okay. And that is given over here in length of vector v. Look at here, x1, x2, x3, x1 square, x2 square, x3 square. Length is given in this way. So I the length of these two vectors, and then the additional problems 9 to 12 from your exercise. Same, exactly same thing, scalar multiplication. And last part, you can see the end. I finished my syllabus, guys, exactly in time. Happy? And that's the end of your course. Just take your last exam and you are done. There is no final for this course.
Right.
Sorry, I just want to let you know I showed up like a few minutes late.
Who? Yeah, please, if somebody is late, please let me know.
Yeah. Whoever takes roll, can you get that? Who is it?
What's your name?
Whitaker.
Okay.
Yeah. Thank you.
Okay, guys. So again,
Zone is also a little late. I think Thane, you the one taking roll.
Yep.
Yeah.
Who
Thanks,
is it?
bro. Sanzone.
All right.
Thanks, bro. Is our test
Sir.
Wednesday?
I'm listening to you.
Sir, seeing as how we don't have anything else planned for the last class on Monday, would you be objected to having class on Wednesday be a review for any kids that have questions and then take the class on Monday? It's just an idea. I'm not speaking for everyone.
That
obviously.
would be incredibly helpful, sir. That would also allow us to.
In my opinion, it won't be that helpful because what I'm thinking is if you take your exam day after tomorrow, in that case, I can return your exam soon, the weekend, and we can discuss about the exam on Monday. Or if you want the exam on Monday, I don't mind. It's you guys. I don't.
Yes, sir. I prefer it on
I'm
Monday.
always help. I'm always here.
on Monday, sir.
No, if you have another test, that's on my lookout, please, guys. So don't say that I have 2 tests or 3 tests. Say your other instructor to move your test, please.
Is that a yes, sir?
If you want to learn really, and if you want the exam on Monday, okay, fine.
Sir, I can't do it on Monday.
Oh.
It'd be Cox.
So all of you guys want your exam on Monday, right?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, I don't mind. That sounds good. Because actually I wanted to use my weekend so that I can grade your exams, but that's fine. Sounds good to me. So day after tomorrow, we are just try to solve your doubts. And Monday exam.
Yes. Sounds great, sir. Thank you.
Don't ask me doubts from the practice test. I'm not going to solve that one. That is your homework. So please, I can solve similar examples, but not the practice test.
Okay.
Okay. And before we start the review on Wednesday, I want all you guys to go over completely your practice test.
Yes, sir.
Working on the practice test, there is no point to go for the review. Make sense?
Yes, sir.
Yes.
All of you, please go over the practice test problems before we start the review day after tomorrow and Monday exam, last day of the class. Okay, guys, thank you so much. And
thank you, sir.
If you have any questions, still we have time. We can discuss.
All right.
Okay, fine. So I will see you guys on Wednesday, right?
Yes, sir.
Davis? Nathan Bayer, please work hard. Okay, Nathan, I'm talking to you.
Yes, sir.
Yeah, please.
So the test is on Wednesday. What did you say was on Monday?
Test people, they don't want the test on Wednesday. Test is shifted to Monday. Agree, guys? Repeat.
Oh, it's moved to Monday now?
Yes.
Perfect.
No, guys, or you want Wednesday?
No, I'm perfectly fine with Monday. I was just
Okay.
making sure so I don't like.
Okay, fine. Monday.
Yeah. Thank you, sir.
Tomorrow revision. Before revision, homework must be done.
Yes, sir. Thank you.
No problem, guys. Any more question? Any more question? Shall we stop here? Shall we stop here? Oh my God. Say something.
Sure.
Okay. Bye, guys. Take care.
Bye.
Stay healthy. Stay happy.
Bye.
Yes. Bye.